So here is every single triangle concept that you need to know in order to prepare for your SAT math. Welcome to the 25 SAT math concepts video summaries. Today we are going to cover triangles, everything related to triangles. Now just make sure that I won't be able to cover the questions which are associated with these concepts because it won't be possible for me to put everything in a single video, but I'm gonna try my best to cover all the concepts. So if you know all these concepts, then there is nothing that can be potentially asked in the SAT math apart from these concepts. So about triangles, the first one is angles of a triangle. And just in angles of a triangle, we have four concepts. So angles of a triangle is kind of one big concept. Then under this there are four smaller concepts that you need to know. So let's say that we have a triangle ABC. So the first concept is angle sum theorem. These concepts are, you study these concepts in your grade 6 or grade 7 or grade 8, but this is just the summary of everything that you should know about triangles. So the first one is angle sum theorem. And it says that the sum of all three angles of a triangle is equal to 180 degrees. So if these are the three angles, so this theorem says that angle A plus angle B plus angle C is going to be equal to 180 degrees. This is going to be really useful. Then we have exterior angle theorem. So for exterior angle theorem, I am going to draw an exterior angle. So let's say that we extend one of the sides of the triangle. So I'm extending this side. So this point was C, and let's say that this point is E now. So next we have angle sum theorem. I'm gonna write it with a different color. Sorry, not angle sum theorem, it's exterior angle theorem. So this one says that if there is an exterior angle, so for example this one, this is an exterior angle and the name of this angle is angle ACE. So this angle is going to be equal to the sum of two interior opposite angles. Okay, so the interior opposite angles to this one, let me change the color. So to this one, it's going to be this one and this one, interior and opposite angles. So angle ACE is going to be equal to the sum of angle A and angle B. That's your exterior angle theorem. Third, we have isosceles triangle theorem. Now let's assume that this triangle is an isosceles triangle. Just write down in the comments what is an isosceles triangle. Okay, I'm gonna tell you. Isosceles triangle is a triangle in which two sides are congruent. So let's say that here triangle ABC is an isosceles triangle with side AB and AC as congruent sides. Third, we have isosceles triangle theorem. So in this figure, ABC is isosceles with AB and AC as congruent sides. Then this theorem tells us that the angles opposite to the two congruent sides are also gonna be congruent. So the angles opposite to these two sides are gonna be this angle and this angle. So if your AB is congruent to AC, then that means that angle B is also congruent to angle C. That's your isosceles triangle theorem. Okay, so this completes your first concept, angles of a triangle. This is all you need to know about angles of a triangle. Next we have Pythagorean theorem. Pythagorean theorem. Okay, so Pythagorean theorem is only applied in right triangles. So I'm gonna draw a right triangle first. Let's say that this is a right triangle ABC with angle B as a right angle. So we all know that Pythagorean theorem says that square of AC is gonna be equal to sum of squares of the other two legs. So this is gonna be AB square plus BC square. That's it. That's your Pythagorean theorem. Now this here we have two corollaries of Pythagorean theorem for special right triangle. So this is all about your second concept. The third one says special right triangles. Now you could have, so there are two types of special right triangles. One is your 30, 60 and 90, and other one is 45, 45, 90. Now SAT loves to give questions on these special right triangles. So this means that you have a right triangle in which one angle is 30 degrees, one angle is 60 degrees, and one angle is 90 degrees. And the second one says that you have a triangle in which one angle is 45, 45 and 90 degrees. So if you apply Pythagorean theorem in these triangles and you apply trigonometry, so there is a very special relationship between the sides of such triangles. So first let's talk about 30, 60, 90. So let's say that this angle is 60 degrees and this angle is 30 degrees. And this is obviously the right triangle. So in such a triangle, the hypotenuse, so I'm gonna just give them names. So let's say that this is C, this is A, and this is B. Okay, so for this type of triangle we have a relationship which says that the hypotenuse is twice as long as the shorter leg. Okay, so the hypotenuse is C. Hypotenuse is twice as long as the shorter leg. So which one will be the shorter leg? So remember that the side opposite to the shorter angle is the shorter side. So 30 is shorter than 60, so B is the shorter side. So this is C is going to be 2 times B. And it's also gonna be, and the longer leg is root 3 times as long as the shorter leg. So the longer leg is gonna be opposite to 60 degrees angle, so A is gonna be root 3 times as long as the shorter leg. So this is something that can come really handy while you're trying to solve problems of some special triangles, and SAT loves to give questions on special triangles 30, 60, 90 and 45, 45, 90. But if you're wondering that from where does this relationship come, so this actually comes from trigonometry, which by the way you also have to do for SAT math. You should know what is sine of 30 degrees, what will be sine of 60 degrees. So these are nothing but just these ratios. Let me know in the comments how will you get these two relationships. Okay, so that's about a 30, 60, 90 triangle. Then we have a relationship for 45, 45, 90 triangle as well. Okay, so now we have a 45, 45 and 90 triangle. So let's say now this is 45 and this is 45. So in this case this becomes isosceles triangle, right? So here A and B are going to be same. A will be equal to B. So in this type of triangle we have the hypotenuse, your hypotenuse, which is C, that is equal to root 2 times as long as any of the two legs, because both the legs are congruent. So this is going to be root 2 times A or root 2 times B. Let me know in the comments how do we get this relationship. So this completes your third concept, special right triangles. Then the fourth one is the most important concept. SAT people love giving questions from similar triangles and similarity. You're definitely gonna get one question, minimum one question from the concept of similarity. I can personally give you guarantee for that. I can personally vouch for that. I can personally give you guarantee that you're definitely gonna get one question from similarity. Okay, similar triangles. Now I'm not gonna teach you what are similar triangles because this is something that you must have learned in your grade 8. Oh, what the hell, I'm gonna tell you. So the similar triangles are those triangles which so any two similar figures are, they grow in proportion. They grow in the same ratio. So here you can see that there is a big triangle and there is a small triangle. But the thing is that they're growing at a similar rate, you know what I mean. Now the thing is that in similar triangles, what you should know is there are three important concepts that you should know in similar triangles. First concept is that the corresponding angles of similar triangles are congruent. So A, B, C, D, E, F. Now if I am saying that triangle ABC is similar to triangle DEF, then the corresponding angles will be congruent. So angle A will be congruent to angle D, angle B will be congruent to angle E, and angle C will be congruent to angle F. So here angle A and angle D will be congruent, angle B and angle E will be congruent, and angle C and angle F are going to be congruent. That's your first concept. Second concept is that the ratio of the corresponding sides is going to be same. So that means that the corresponding sides are going to be in proportion. So what do I mean by that? So if you take the ratio of AB and DE, that's going to be same as the ratio of BC and EF, and that's going to be same as the ratio of CA and FD. So that's your second concept that you should know. The third concept is about triangle proportionality theorem. Triangle proportionality theorem. Now this one says that if you have a triangle, okay, let's say that you have a triangle ABC and there is a line like this, and let's say that this line is parallel to the base. So this line is parallel to BC. So let's say that this line is XY and XY is parallel to BC. So in this case, your XY divides the two sides proportionally. So XY, the line segment XY is dividing the line segment AB and AC proportionally. Okay, you have to let me know in the comments that how is it happening. So third concept is, first I'm going to write it down. XY divides AB and AC proportionally. What that means is that your AX over XB is going to be same as AY over YC Now let me know in the comments that how is that happening, and also the ratio of the entire side. So your AB over AX is going to be same as AC over AY. Let me know in the comments that how this is happening. This is actually a corollary of the second concept. Okay, so this completes the concept of similar triangles. Then last but not the least, we have area of a triangle. So we all know that area of a triangle is given by, I'm gonna copy this triangle. Let's say we have this triangle and we have to find out the area of this triangle. So in order to find out the area of a triangle, you need the altitude. So you are gonna need a height. So you are gonna need the length of this. You're gonna need the length of this height. So let's say that the length of this height is h, and let's say that this point is G. Okay, so area of a triangle is given by the base times the height and divide everything by 2, or 1/2 times the base times the height. Now if I'm considering this particular height dg, so I get half times height is dg, and the base becomes this one, EF. Okay, so this becomes EF. Let's say that the length of the base is b units, so we get 1/2 times b times h. Now it's not necessary that you only need to know this height. You could also have, so the SAT people could also give you this height, you know, this height. So in this case your formula will remain same, but the values will change. So for instance, let's consider that now this is O, and let's consider that length of EO is h units. This is h. So and then in that case you're gonna take your base as df. So now your formula, your area will be half times your base is gonna be df and your height is gonna be OE. Okay, so it does not matter that which side you're considering. Just remember that the height should be the perpendicular drawn from the vertex opposite to that side. So this base can be any side of the triangle, and the height has to be the perpendicular drawn from the opposite vertex at the base. So that's about area of a triangle. There is one more thing that I need to tell you about area of equilateral triangle. So if you have an equilateral triangle, by the way, an equilateral triangle is the one in which all the three sides are congruent. So let's say we have this equilateral triangle and all the three sides are congruent. Let's say that each side has length A units. So this is a very special triangle, and you don't need to find out the height, perpendicular, base, nothing at all. You just need to know the length of one side, and then the area of equilateral triangle is given by √3/4 times square of the side. So that's it. That covers all the concepts of triangles. And the thing is that just by doing the concepts, just by revising the concepts, there is no guarantee that you will be able to ace the SAT math unless you practice different types of problems. So you know, even there is not going to be a direct problem on Pythagorean theorem. There is not going to be a direct problem on area of a triangle, but these concepts will be clubbed with some other concepts. For example, they'll give you a circle, and inside the circle they'll give you a triangle. So here you might need to apply the concepts of circles as well as the concepts of triangles as well as the concepts of trigonometry, you know. So SAT people are not going to give you direct questions, the questions that you have been doing in your school. The questions are going to be tricky, so you need to practice different types of questions, how a question can be asked in a different way. So the more you will practice, the more you will understand. And at A+ Calculus, I have done years of research, and I know that how a question can be asked in 4 different ways. And what SAT people do is they don't draft entirely new questions, they reuse and recycle the old questions, and you know, they just modify the language or they modify the way it has been formulated. So there are, if you consider, let's say, similar triangles. So for similar triangles, there are 4 ways in which a question can be asked. So the moment you look at a question, it should strike you that they are testing the concept of similar triangles. So SAT is all about looking at the question and thinking, okay, they are testing me on similar triangles. It should just take you 2 seconds to identify that which concept they are testing you. And don't worry, it's all about the confidence. The more you practice, the more confident you'll become. That's it for this video. I'll see you in the next video. Bye bye.